Hello everyone, welcome back to my channel. So in our earlier video we have seen about the theory part about drag and lift forces. So now we will see numerical problems related to drag and lift. So let's see the first problem. A thin plate is moving in still atmospheric air at a velocity of 5 meter per second. The length of the plate is 0.6 meters and width is 0.5 meters. Calculate thickness of the boundary layer, drag force on one side of the plate by taking density of air as 1.24 kg per meter cube and kinematic viscosity as 0.15 stokes. Okay, so first let's quickly write off the given data. So what is given to us? So it is given that the velocity of the air, here we take it as u, so u is equal to how much? 5 meter per second, and length of the plate is given L as 0.6 meters. Even width of the plate is given, which is small v, which is equal to 0.5 meters. If you look at the other given data, density of the air is given, which is equal to 1.24 kg per meter cube, and also kinematic viscosity nu is given, which is 0.15 stokes. So we have to convert this stokes into meter square per second. So we convert this stokes as 0.15 into 10 power minus 4 meter square per second, because since 1 stoke is equal to 10 power minus 4 meter square per second. To know this you know calculation or the conversion, you can check out my video of viscosity in fluid mechanics playlist. Okay, so this is our given data. He is asking us to calculate the thickness of the boundary layer. To calculate the thickness of the boundary layer, initially I should know whether it is a laminar boundary layer or a turbulent boundary layer. So for this we will calculate the Reynolds number first. So Reynolds number is given by the formula Re is equal to U into X by nu. This I have already shown in my boundary layer video. Here our X changes to L, because here we are going to calculate over the entire length of the plate. So hence our Reynolds number changes to the formula U into L by nu. So let me put up the values. So what is the value of U? We have 5 into the length of the plate is 0.6 by kinematic viscosity is 0.15 into 10 power minus 4. So from here our value of Reynolds number change comes out to be 2 into 10 power 5. So I already told you for laminar boundary layer Reynolds number should be less than or equal to 5 into 10 power 5. So for us it came 2 into 10 power 5. Therefore we say that the boundary layer is laminar. So once we understood that the boundary layer is laminar, then accordingly we can switch on to formulas for calculating drag force, because we have thickness of boundary layer also, because the thickness of the boundary layer formula is different for laminar boundary layer and turbulent boundary layer. So compulsory first thing is that we have to calculate the value of Reynolds number. So from in this uh, problem, we understood that Reynolds number is 2 into 10 power 5. So the boundary layer is laminar. So now we will start calculating the thickness of the boundary layer first. So to calculate the thickness of the boundary layer, let's write the formula. So first I am going to calculate thickness of boundary layer. That was the first part of the question asked to us. So for a laminar boundary layer, according to Blasius, delta is equal to, that is the thickness of the boundary layer is equal to 4.91x by root Re. This formula is also discussed in the earlier videos. So from here let's calculate for delta. So 4.91 into, here again x is becoming L because we are going to calculate over the entire length of the plate. So delta is equal to 4.91 into, what is the length of the plate? We have 0.6. So sorry, yeah, it is 0.6 into 0.6 by, what did we get Reynolds number? 2 into 10 power 5 by under root of 2 into 10 power 5. So from here our delta comes out to be around 0.00658 meters. Okay, so we cannot write this way of representation for a thickness, so we will write this, we will convert into mm. So this becomes 6.58 mm. So this is how we calculate the thickness of the boundary layer. So our first part of the question is done. So what is our next part of the question? It is calculating the value of drag force on one side of the plate. So let's calculate the drag force on one side of the plate. So drag force is given by Fd. So basically the formula for drag force is Fd is equal to Cd, that is coefficient of drag into half into rho into A into u square. This is the formula for drag force. But first initially we need to know the value for coefficient of drag. So we know that for laminar boundary layer, because our boundary layer came out to be laminar, so for laminar boundary layer the CD formula is given by, this is also is discussed in the earlier video, so please check out the video for the formula. So it is 1.328 by root RE. So this is the formula for CD for a laminar boundary layer. So I will use this formula and substitute for the values to get for CD. So CD is equal to 1.328 by under root of what is RE 2 into 10 power 5. So from here if I calculate, the CD comes out to be around 0.00296. Okay, it is a coefficient, so do not put any units for this. So now I will calculate the value for Fd. So therefore Fd is equal to, what is CD? 0.00296 into half into, what is the value of rho? Density of air is given as 1.24. Next is A. A is what area is? A is area of the plate. So area of the plate, this is a rectangular plate. So area of the plate will be L into B. So A will be equal to L into B. What is length of the plate? 0.6. Even B is given, width of the plate 0.5. So here it becomes 0.6 into 0.5 into u square. What is the velocity of the stream given to us? 5. So it is into 5 square. This is how we substitute and solve for Fd, and finally our Fd turns out to be 0.01373 approximately Newton. So this is how you calculate drag force on one side of the plate. So let's see another problem on drag force. So here let's see the question. A plate of 600 mm length and 400 mm wide is immersed in fluid of specific gravity 0.9. Kinematic viscosity is 10 power minus 4 meter square per second. Fluid velocity is 6 meter per second. He is asking us to calculate thickness of the boundary layer, shear stress and drag force. This is similar to the earlier problem, but here extra we are calculating shear stress also. So first of all let's write the given data quickly. So if you look at the given data, the first point we noted down is the length of the plate. So length of the plate is 600 mm, so which is equal to 0.6 meters, and width of the plate is given to us, which is 400 mm, so this should be equal to 0.4 meters. We have specific gravity of the fluid given as 0.9. Once we know the specific gravity, we will calculate density as S into 1000. So this is equal to 0.9 into 1000, so which is equal to 900 kg per meter cube. And kinematic viscosity is given as 10 power minus 4 meter square per second. It is already in SI unit, you will not convert. Okay, and finally stream velocity is given as 6 meter per second. So he's asking us to calculate the thickness of the boundary layer, shear stress and drag. So to calculate these values, first initially we need to know whether the boundary layer is laminar or turbulent. So first thing what we have to calculate is Reynolds number. So Reynolds number is given by the formula U into L by mu. It is ux by nu, but x is the entire length of the plate, so U into L by nu. So 6 into this is 0.6 by nu is 10 power minus 4. So this turns out to be 3.6 into 10 power 4. As we know that if Reynolds number is less than or equal to 5 into 10 power 5, the boundary layer is laminar. So now it is 3.6 into 10 power 4. So obviously the boundary layer is laminar. So we will see the formulas for laminar boundary layer. So coming to the first part of the question, the first part of the question is calculating the boundary layer thickness. So how to calculate the boundary layer thickness? So to calculate the boundary layer thickness for laminar flow, the formula is 4.91x by under root RE, which is like the similar to the earlier problem. So it is 4.91 into x is L here. So again 0.6 by under root of 3.6 into 10 power 4. So after substituting this, our value of boundary layer thickness comes out to be around 0.0155 mm. So we write this as 15 point, sorry, this is meters, 0.0115 meters. So we write it as 15.5 mm. Okay. Now moving on to the next part of the question. The second part of the question was asked as shear stress. So we will calculate the shear stress. So shear stress is given by the formula tau naught. You can check the earlier video of drag forces where I discussed the formula for shear stress also. So shear stress for laminar flow is given by the formula 0.332 into rho u square by under root of Re. So from here it is 0.332 into rho is 900 into u is 6 square by under root of 3.6 into 10 power 4. So from here our tau naught turns out to be around 56.6 Newton per meter square. So this is the formula for calculating shear stress. And let's move to the last part of the question. The last part of the question is calculation of what drag force. So let's calculate the drag force. So drag force is similar calculation like the earlier problem. So we have the formula of FD as half into CD into rho into A into U square. So first let's calculate CD for laminar flow. So CD for laminar flow is given by the formulas 1.328 by under root of Re. So which is equal to 1.328 by under root of 3.6 into 10 power 4. So from here CD comes out to be 0.00699. So once you get the value of CD, let's calculate FD. FD is equal to half into 0.00699 into 900 into area is again a plate, so it is 0.6 into 0.4, that is length into width, and into u square is 6 square. So if you solve this, you would end up with a value of around 26.78 Newton. This is how you calculate the drag force, shear stress and thickness of boundary layer. So I hope all of you understood the video, and thanks for watching.